Hello, wonderful people. Welcome to another show of web performance. Today we're talking about Purple. For those who happen to follow the series, if you check down there in the description below, there are 2 additional links to the previous 2 live streams. So if you want to catch up about all things web performance that we're doing over here at this dot, you can find the links below. So as we get kicked off and started here, I am your trainer today, Justin Barrow. I'm still the EVP of Web Platform Engineering. Apparently the second show, I get to keep my title. Over here at this Labs, you can always follow me on Twitter for all your Twitter and particular Twitter tweet style needs. I am out and about over there. And you can always find me online in other various places. You can also send me an email, which you'll find on my secret website. It's not that secret. It's out there on the public domains. And before we get into the heart of just rendering with that shade of purple just a little bit faster for all your web performance needs, do you find that keeping up with the constantly evolving technologies is a struggle? I know I do. Do you want to bring your team up to speed just a little bit faster, a little bit quicker on the latest and greatest web technologies, or any technology for that matter? Hey, don't worry, we've got you covered. This Labs offers personalized training programs to suit your organizational needs, ensuring you and your company stay on the leading edge. Do contact us today at hi@thisdot.co to set up your complimentary needs assessment. And as per usual, we're also sponsoring this show this week. Hey, this Labs. I just told a whole bunch about us. Also sponsoring this week, coffee. That's right, coffee's back for the second week in a row. Tara, thank you so much for getting coffee as a sponsor this week. I appreciate it. I know you worked tirelessly to find me that. And if you're wondering why there's a camera in that picture, that's also my camera, because not only am I leading the technology front, I'm also using an old school camera just to keep it real. So last week, we went over some general rules when we talked about web performance, things that I try to live by, and I hope that you might too, to help your web performance overall goals feel a little bit better, just a little bit faster in the world. Number 1, keep in mind, performance is relative. What's fast for you doesn't mean it's fast for the person on the other side of the globe, right? You got to keep in mind that the speed of light is indeed currently constant until the physicists tell us otherwise, which basically means, hey, you got to keep into account all the things that could happen between you and where you're serving things. So always be testing across a wide range of devices, a wide range of connections. Understand that just because it works on your machine is not a proper answer to a question ever. Number 2, performance is generally relative. Just because that loading time is, says 10 seconds, is it truly 10 seconds? Did it take 10 seconds of a white screen to show me the end result? Or did I render something very quickly to get my users started so that they know things are happening and I'm actually giving them content that they want? Again, just because your loading times look the same on 2 different things doesn't mean that's the exact perception that user is experiencing, right? Maybe you've locked up the main thread. Maybe other things are happening where they don't have an interactive state and they can't click that link to get to the thing you really want to convert them on. These are things you have to keep in mind when you think about performance in perceptions. And number 3, performance is a lot of the times about reduction. Hey, less JavaScript. I know you want to write less JavaScript. And no, I don't mean just because you can write TypeScript. No, ship less JavaScript. Do us all a favor out there, internets and intertubes. Ship less things, less network resources, less main thread time, render faster, composite, paint, all these things. It's a reduction of the things you need to do. So a lot of times we're talking about performance, we're talking about reduction. And speaking of which, I had a question in the old mailbag after last week's episode. The old mailbag, hey, thanks a lot, Greg, for sending this question over. They asked if the actual performance fix I had put in last week for the CSS style actually made any actual real user difference in the span of the week that it was actually live on my website, of which we've been picking apart here because I don't want to pick apart anybody else's website because that might be considered harsh. To your question, Greg, yes, indeed. According to the real user metrics that I've been pulling out of Firebase Performance Panel, the synthetic metric that we saw last week in last week's video, do check it out. It's in the description below. we were seeing about a 200 millisecond gain in the synthetic tests running against, just tracing it in DevTools. The real user metrics out there in the wild for my site currently shows about anywhere from 100 to about 150 milliseconds of time. So it is indeed saving us paint render time. Yay for reduction, which, hey, is number 3 on our list. So thanks for the email, Greg. I appreciate it. So what are we talking about today? Today, we're going to talk about purple. Particularly, it's a lovely shade. Sometimes I see it on the horizon after a long day of writing code while sipping tea and or coffee, because I miss coffee. It's been a rough quarantine. So the reality is that a lot of times when people hear the word purple, or rather the acronym purple, they often think of Polymer because Polymer sort of coined it way back when. But this ain't about Polymer, yo. This is the concept around the pattern. A lot of people think, oh, this is only a web components thing, or this is only a Polymer-based thing, and it's only specific to this instance. And the reality is that just because they coined it doesn't actually make that a thing. Like, that's not really the point of the pattern. As you will quickly see, as we start to wander through the wonders that that purple gives us when we talk about web performance. So, and I know this because your framework has a guide for this pattern. Yes, that's right. I've read them. They will indeed make your framework-based web applications faster, so stop making excuses. A lot of people say, I can't apply this thing because my framework looks like XYZ. No, that is not an excuse. There are guides out there. As a matter of fact, if you search for purple right now, I believe the Gatsby guide comes above the actual Polymer original article, which I think is hilarious, which just shows you how far the pattern can be pushed. You can push this pattern in any framework you have. It is not framework specific. It works with the notions of what the platform will give us and the things that we can do to make our users' lives better. So please, stop making excuses. Do a little bit of reading while you're at your desk. So, what is purple? I keep saying the actual words, and I would generally show you the color purple, but I don't know how your screen's calibrated. I don't know how you work internet. So realistically, when you hear the word purple, you can think of it as a fancy acronym that is just for the pattern to ideally make all of our stuff faster, right? It's just a series of pattern principles that allow us to do certain things. So we're going to go through each letter to sort of get a gauge about not just what that letter means, but also how we might actually web perf test this. Because it's key to understand that just because we have an acronym for something doesn't magically make it a thing. Like, we do have to write code and measure and do the tooling like we've done in previous episodes, but also just in your daily job, the things that we're often common doing. So let's start with that first P, push hours or preload. And this is one of those things that, there's a lot of literature out there about this. This gets a little bit complicated when you get down into the nitty gritty of just how fast you can make your performance roll. But realistically, it's really about those important and critical resources that you need to get to the client to make that experience fast. So when we talk about these things, a lot of times we think of the waterfall in the scope of our site, where we have this big cascade of stuff, right? And some of those things are more important than other things. Maybe you don't need that ginormous off-screen rendered image as a top priority in your load order. Maybe you should also parallel load these other two things, using the fact that H2 will allow us to do these things. So we want to be able to tell our browser, hey, these things are important. I want you to load certain things. Do that for me. And from a trace perspective, we can actually trace this because Lighthouse in particular will surface this as preload key requests. So if you run a Lighthouse report, which we'll spin one up here in a second and see if we can get this whole thing to kick. Preload key request is going to sort of help you understand, like, hey, like, I actually needed this thing a lot sooner than you sent it to me. Could you send it to me a little bit, quicker into the future of things? Because at the end of the day, we want to surface things that are useful to our end result, right? We're trying to get somewhere for our page. And it's going to vary. Again, performance is relative, and so is the thing that you're delivering to your user. What I deliver as important may not be important for you. Maybe you have something else that is higher priority for you in the land of things. So realistically, what does this kind of look like? So let's switch screens. And I just realized there's no trace window on here. We can remedy that. Boop, boop, boop. Drag this over here. Let's run an audit. Yeah, sure. Give it to me all. Boop. And in this case, we're just going to run the audit straight in DevTools. And this is DevTools stable at the moment. We'll see how well this works, given the fact that, oh, wow. Yay for us. Fireworks. So, let's go down here and take a look at what's going on. So we've talked about some of these numbers before, just in terms of stuff. Realistically, we can go into past audits and look and say, hey, so we also have things like pre-connect to required origins, which we're going to show you in code here in a second. And then we've got preload key requests, which use link rel preload, so that we can tell things, hey, prioritize this thing for us. And again, you will quickly note, I just opened up DevTools, ran an audit, and now I can see things that, based on the structure of the thing I'm trying to render, it's trying to tell me, hey, these are things that you need to do. Now, keep it in mind, if you've seen the previous episodes, I do some of this in the forefront of things. So we're going to switch windows again. Boop. So if we look through here, and I'll make this a little bit bigger, boop, boop, we can see that actually in the index page that for this particular little progressive web app that for blog.pdgria that runs this actual site for my blog and other random things, you can see that I actually do quite a few pre-connects to make sure that my DNS is primed and ready. Because again, we want to make sure that we're preloading those things that are important to us. And one of the things we want to cut down on is the round trip time for DNS calls and TLS handshakes. So these can be expensive depending on what kind of origin you're connecting to, where exactly you're trying to go, how many of those things are there. In this case, I'm pre-connecting across the board for things that I know that I will eventually connect to at some point. Now, I'm not saying I'm connecting to all these things straight out of the gate to go get resources from them. This is not a resource download in this case. And you'll quickly go, well, hey, I thought you were actually like preloading or pushing things to the browser. And in this case, you can do this a couple different ways. One is that you can use the link rel preload within the notion of your head to actually do this. I actually do this a different way. You can actually use headers straight across the board. And so what I end up doing is I push link rel preloads via Python on Google App Engine in this case. And again, you can do this a variety of ways. It's just one example of it. But basically what happens here is that I'm saying, hey, like I'm going to preload and push certain types of assets that I find to be quite important. And the server will go through when that first request comes in for a page, append these headers onto the request so that we can basically resource hint out and say, hey, I want you to do these things for me before I even ship actually any code to the browser. So I actually don't have to start reading my index.html. I can just push some headers down, tell it, hey, preload these things. And in my case, I also do a little bit of pushing. So if we flip back again, so many flipping, so many screen flips today. Have to find the window. Have to find it. Boom. Window. So we're going to reload this again. And initially, this a little bit bigger too. Big words. So quickly, we can take a look at the fact that there are some pushed resources straight away. So you can see that we're actually pushing this index.json, which is actually what's rendering our base body. Straight out of the gate, this little 2K file, as we've sort of fired up. And if we dig into the actual index request, we can see that not only are there a whole bunch of other headers. So we've got CSP in here for your content security policy stuff. So I've got a huge content security policy thing on this site. Because again, if you want to see just how crazy you could go on a website, the blog.pwa example, which other people have contributed to as well, it has quite a few interesting things in it. One being CSP, which is quite a bear to work with. That's a whole other episode in itself. Same thing with certificate transparency and a feature policy, which is a really cool platform feature. That's another episode. But down here, if we look at link, we'll note that, hey, I'm pushing this as a header. So that Python that we just temporarily looked at, which, by itself doesn't look like much. It looks like, well, I'm appending some things to a collection or a dictionary, and then I'm sending them as headers. Well, that's what this header looks like. So in this case, I'm saying, hey, go down here, grab these things, preload them, so I can use them immediately. And again, some of this is very, very particular to the predictive nature of what I know people have a tendency to load for this site. So it's going to vary based on application to application. And as long as you have some telemetry on these things, you can go ahead and say, oh, good, I know what I need to do. So having some instrumentation, whether that's analytics data or some just general performance metrics that you're tracking to see how people are actually interacting with your site on the fly, is very, very helpful. Like, it can give us the means to say, well, I know I need to preload these things across the board other than just a Lighthouse performance report. So in this case, we can see that, yeah, I've got some headers in here, yippee skippy for me. We can see that these things load in front of my waterfall because these are things I'm actually pushing, because this gets my site to that render point very, very quickly. And so that kind of tells the story, right? When we talk about the nature of push and preload. I can push a resource down and say, I need this right now. I can preload that resource so that it's immediately ready when my thread starts up and I actually need to do other types of work. And again, this goes also to the fact that the base index page, as I'm actually sort of rendering this content, also has some inline critical resources, which we talked about last week, and we're going to revisit here in a second. So push and preload are very key topics. You can get a lot more perf out of them as needed. And let's move on to our next magical sort of window of things. Make that screen a little bit bigger. Boom. So if we're preloading stuff, well, we still have to actually, render things, right? Like, just because I've preloaded some things doesn't mean that they're the right things, doesn't mean that my render is going to be fundamentally okay, right? We want to make sure that that we're doing the right things to get us to that render. And one of the key things is that we want to render the initial route very, very quickly. So that R is all about that initial route, not the route 3 clicks down, not the thing that only 5% of your users use on a Thursday every other month. Not that stuff. Those are not things we want to render initially, right? So we want to get out of our way to get to that point. So we can paint. And there's a lot of tooling in Lighthouse that sort of helps tell us these things. But in particular, one that you're looking for is eliminate render blocking resources. So this is one of those things where you definitely want to understand the way your page parses, what those script resources and CSS files are doing to your overall render block situation, and what's actually preventing how much time you're going to save. So Lighthouse will tell us this. Lighthouse will tell us straight away, hey, I've got a resource in here. I don't want this to get in my way, fundamentally. So if we come down here to render blocking resources, we can see in this case, my site doesn't actually have any render blocking resources in there. And again, this is in particular because we apparently I am somewhere else. So come back. There we go, screen. Whew. So in our case, we know that we're not really render blocking on style for this site because, as we learned last week, I inject critical styles straight. So critical styles get injected straight, the components fire up other stuff as part of the progressive web shell that's there. So we know that we're not going to get a render block within a style sheet because we're not actually loading anything. Similarly speaking, I lazy load all the Google fonts straight away so they don't cause a render block, which gets me another 200-ish milliseconds of time across the board. And again, similarly, we gain another 200 seconds of time by changing the nature of the animation that actually renders for the little tiny load skeleton on slower connections. All this stuff is, again, non-render blocking. Similarly speaking, we don't have any scripts in the head. The only primary script is an injected script to deal with first input delay. So You don't want to block up your head with a whole bunch of stuff that's going to sit there, take a whole bunch of parse cost and hit. Now, browsers have gotten smarter as time has gone on. They do a much better job at sort of trying to free and let the page continue rendering, but that doesn't mean that all things are sorted for us. That's why this still exists within our performance reports, and part of our audits is that we don't want to end up with this thing. And to some extent, this also goes to main thread work. So, you're going to look at your style and your layouts and your script evaluations to see where it is. Even here in this last run, you see a lot of style layout burn, which I've noticed more recently has been problematic. Similarly speaking, you can see, no efficient cache policy. Again, all these things are not necessarily render blocking, but they do prevent you from getting there quicker. So you want to make sure that you're removing any barriers that you have between where that first paint is and where it is not. And again, some of that might be on the server side. Again, I'm pushing critical inline stuff as opposed to just huge bundles of data, or it could be other critical sort of chains where you're just sort of reducing. Trying to make sure that one thing doesn't require a thing four deep down your critical request chain. So if we can render quick and we're sending stuff down and whatnot, well, what's that other P for exactly? Because really, you're like, well, Justin, I've pushed some stuff. I got preloads and pre-connects. Like, I got a really short time gap, and this all works out fine. And I think I'm good to go. But realistically, that's not how people use your site, or at least I don't think you want them to, right? You want them to stick around. You want them to do things. You want them to see the world through your site, because at this point, we're all trapped indoors. So the key is that you want to sit there and go, well, I want to make sure that the rest of my site is fast as they start to use it. So maybe after that first paint, what we should think about is the next P, which is pre-cache remaining assets. So you've rendered some stuff, and now let's try to be a little bit more predictive about other things that may occur. So how does one trace this? You might quickly answer. And the question is, you really don't. From a Lighthouse perspective, you don't really know what your next path is. Now, mind you, you might be able to request and trail that path through much more complicated means. And we'll sort of talk about those things in an upcoming episode where we talk about CI and integration and how you get these things to work in a much different way. But from I'm trying to trace my website standpoint, not really. Like, you're not going to necessarily trace this, but you do want some data that you have to figure out how you're going to do this. And there's a number of different ways you can do this. One is that you can use Service Worker. You can use Service Worker to basically pre-cache additional material and or routes so that your user has that stuff available for them instantly. If you don't want to use Service Worker for whatever reason, you can actually technically use the Cache API, which Service Worker interacts with. You can use that directly. So you can use it through your own sort of little tiny request layer to push your own assets in. Same thing with IndexedDB, other sort of storage methodologies on the web. The platform gives us a lot of tools around this to be able to cache the things that we need to cache in a way to give it back to users in a much more quick fashion, whether it's a progressive web app or not. So again, a lot of times when we think about applications, we think of these huge structures of things. But that doesn't mean that you can't do this with single statically generated page engines. You can do the same exact thing, be it whether you're using Workbox for your service worker or some other method that you've got. Maybe you've got a Webpack config that generates that for you. You can make these things work, but you still have to know what those critical things are. And again, that's going to come down to you. Maybe you hint that, maybe you don't. But realistically, I can show you one example. So one example here is that I know that things that load within the base route within the blog to PRPL example actually makes sense to sort of handle within the structure of a service worker. So in this case, if we look at blog PRPL and we come over here and we scroll down here. So in this case, and I've got this little function. It's a little lazy load function, which we'll talk about here in a second. It also has this nifty little hook that once the service worker is activated and I'm in a request idle period, maybe I should do some work. Maybe I should do and cache some existingly loaded URLs so I actually don't have to go get them again. So again, this is a particular methodology to yank performance out. with the purple pattern. The idea that I do want to pre-cache not just stuff I want to go get in the future, but stuff I already have so that I don't block my thread. So in this case, if we jump down here, we can see that, hey, I'm going to go and find my base route wherever I am. I'm going to go get all my resource maps out of my performance entries by type in this case, right? And then I'm going to tell the service worker, in this case, workbox is message SW comes in handy here, cache these URLs for me, do me a solid. At which point it'll cache these URLs for me, and I can now use these things to all my heart's content. This recipe is not magic secret sauce. It is in the documentation. And I highly recommend it when you know exactly what you want to do and you want to gain 150-ish milliseconds on the front side if you don't want to cause a service worker hiccup, particularly on low-end stuff. On high-end stuff, I found it to be negligible. But again, we're trying to eke out every last bit of perf we can out of this. So again, we want to cache existing loaded URLs too. So I go through, load these things up. Now my service worker, my little progressive web app thing will work. This also triggers other sort of subsegments. So it does have a pre-cache in it that post base load, it'll go and grab some other stuff as part of the workbox config. So we're down here. We can look at particular glob pattern stuff. And again, like a lot of this I do through Workbox because Workbox makes this particularly easy. You can build this any which way from Sunday without any particular need. And then of course you've got all your routes and things. So how you decide to sort of deal with that pre-cache event and what you want to cache is going to be, again, very specific to your need and relative to what you want the user to do next. Let us switch back. We're just switching slides like crazy today. And now let's round out our acronym. Got to round it out. L, lazy load, other routes, and non-critical things. So this is the thing that I think if you take one thing away from today, because some of these things I readily admit, they can be very difficult in a pre-existing application if you do not have a great deal of experience with having to do retrofits of this type. But if you do one thing, take heed into the notion of lazy loading other routes and non-critical things. Because at the end of the day, we all ship too much stuff on the wire. Again, this goes back to rule number 3, reduction. A lot of times I look at build configs and I question my sanity. Because the notion of bundle everything into a big giant ball is not a very good notion for an end user. It just isn't. It makes me sad. And it makes your users sad. And it makes their data plan sad. So realistically, you have to sit there and go, well, can I load these things later on somehow after an interaction potentially? Because Lighthouse is going to tell you a whole bunch of things every time you run an audit that has a lot to do with lazy loading. Everything from the notion of really big, huge network payloads, which is a big red flag waving of like, yo, you should figure out how to chunk this and split this up because you can't surely need 400K of JavaScript to make this one page of black on white text render anything. High boot times, high thread time. Like again, like a lot of these things go to the notion of how the parse engine works. Like if I'm having to send all that stuff, I got to parse it, I got to expand it, I got to do all this stuff just to get it ready so I can actually run it. And then the other thing that just kills me all the time is the notion of off-screen images. Like, do not prioritize ginormous, unoptimized images that aren't even in the main view first. Don't. I don't need 1.5 megs of image data that I'm only going to load if I scroll to the bottom because you sort of did not take into the notion that the 26 by 26 icon in your footer doesn't need to be a 1.5 meg GIF. I don't know why. Sometimes these things slip through the cracks. Other times we can do better. So Lighthouse is going to tell you this stuff straight away. We can sort of eyeball that in at least one of these things. If you've got a site out there, by the way, that you're thinking, you know what, Justin, you should trace this site because this site would really show like just all these things you're talking about in a really terrible fashion, do let me know. We can run through one on the next episode, though I will need someone to say, yeah, that's okay. because, it could get ugly in there. But again, you can see large network payloads is a base option in here. It'll tell you straight away where your big files are. You can see that my largest files aren't even my files. They're third-party resources. And then again, this is another thing that people get bit with a lot, is that they load a lot of third-party resources that they're not actually managing within their own tool chains. And they're like, wait, why is my site slow? Oh, well, it's because you load 10 analytics engines. Those analytics engines load 100 and something K per piece, and then you're stuck. So I see this a lot. Everyone gets bit with this when they have 27 advertisers on a site that just wants to pump data. So many of them are really not just enormous network resources. They're just really thread heavy. Patrick put together a really great resource, which I'll put in the description notes for this episode, about third-party resources and just how, what their weight looks like against your site. It's a really great resource if you're interested in, trying to eke out more performance on your site. So these things, again, they'll surface very quickly. You don't necessarily have to show those third-party resources, so you can see exactly, where exactly your weight is for something. Execution time, you can go through and see exactly where it is. Interestingly enough, 103 to 150 is about how fast Google Analytics runs on a good day. Yeah, 100 milliseconds just to run analytics. Not super great. And then, of course, you've got your web fonts and everything else. But again, you're going to look at these things and you're going to try to find and surface them so that you can go, well, I need to go fix them. Because at the end of the day, you don't want them to block you up again, because all these things sort of, as you've probably figured out, start to interlock together. Well, if I'm preloading this thing and it has this amount of weight and I know it's going to do that thing next, then I know, I should just not load part of that. I'll load that other part later, right? These things all sort of go together. So doing one doesn't solve the entire solution to your performance. And again, this is why I harp on the fact that performance is a very relative thing, is that just because you start implementing little bits and pieces doesn't mean they will all fit together. You have to find a cohesive sort of performance baseline that you want to approach and then work towards it all the time. So if we switch screens and actually look and say, well, hey, I wonder how exactly one, lazy loads things. To some extent, we're at a much better position than we used to be. We do have ES modules. We do have async await. We can write nice code that sort of makes our life a little bit easier as a whole. So one way that you can approach this is you can't have modules of certain types. So in my case, as you noticed probably before, I have this little method called load non-essential things and start up the service worker in analytics. This little method, which oddly enough, I documented. Yay, documentation. This does an import. It grabs lazy resources. If we look at lazy resources, we can see that these are things that are not super important to the overall initial operation of the site. You don't need the network warning little module that pops up to tell you, hey, your network's offline when you're reading stuff, particularly in those sort of li-fi situations. You don't need blog missing necessarily straight out of the gate, because that gets taken care of on the server side initially if you try to get somewhere you're not supposed to be. Same thing with the snack bar. Like the snack bar is there for little nifty messages when the service worker really kicks in or you need to do a refresh. These are not things that you need immediately. You want content first. These things are all tack-ons. So I load them late, and I do that with imports, and then an import comes back with a promise, at which point then I operate on the promise. Same thing with fonts. Fonts load late. I inject those straight. And again, like from a route standpoint, I can do this through through routing as well. So I know where I exist in space. Your applications and sites probably do as well, which means that you can make particular choices about how your router does certain things. Every router works a little bit differently. Most of them support lazy loading now, so that if you have something in a base module, you can go ahead and say, hey, well, I'm going to go ahead and grab my static and then do some work on this thing. Or I'm going to grab my entry, depending on where I came from in that load route type. And again, like your routes can be very generic. Again, in this case, I have 3 different types of routes, and those 3 different routes might load against this. We know that missing loads in the lazy load state, so we don't have to worry too much about it. And again, there's not a lot of fancy code here. You can see that there's just literally an await and an import against an async method. So that just lazily loads this thing until I'm ready. Now, you may be wondering, well, Justin, wait, didn't you preload some of these things out of the gate? And indeed, you would be correct. So this is particular to my use case. So I know that based on my analytics, I know within a high degree of what the major routes people will enter in are. So I push those things predictively to make sure I hit one of them. So in a lot of cases, entry is the key one. Entry almost always gets pushed based on what happens on the server to tell it, hey, go grab this first because we're already here based on the route. So, and again, this is based on data, right? I'm not just guessing. You can look at the data, figure out where you need to go, and then figure out which pieces you need to lazy load straight away. And while Lighthouse and related performance tooling, whether you're running just pure traces or not in DevTools, like it's going to tell you these things, but fundamentally you have to go into your code and do the work. Like you can't just expect it to tell you, move this thing around over here to make something faster. There's no turnkey solution for that. You do have to go in and figure out, hey, I'm gonna have to rewrite this piece, or I'm gonna have to, hint out to, my build tool of choice that, hey, this is a chunk here and load that late, or whichever port you need. Similarly speaking, we can do lazy loading of lazy loading of lazy loading, so you get a lot of depth. So one thing in particular is this notion of entry. Entry is special. Entry does its own series of lazy loading within its process metadata method. So entry can be really, really light. Let's say that I just have some text on the page. It's just an article of me rambling on about the latest trend in XYZ. Well, on that spectrum, I don't need it to do much. I don't need to load a whole bunch of other, specific components. But then there are those posts that have other really specific needs. So in my case, one of those needs is the STL part viewer. So the part viewer, when it loads up, it'll load a 3D model. And in this case, what happens is if the blog post contains STL part viewer in it, it'll actually go and grab the 3D utils pack. So in this case, that's just another little component I had written. It lazy loaded in for that particular case when a user views it. And then magically you get that thing for the right time. And again, this goes back to the notion of when do you lazy load something? Is it in that pre-cache of things? Well, do a lot of my users read my, random 3D, design posts? No. So I'm never going to forward load that thing. I'm only going to load it if I absolutely need it. Same thing with code block. Not all of my blog articles require my code block custom element. So in this case, I don't load it. Same thing with light YouTube, another component that I've got. Do I need that one every single time? Nope, I don't. Great. Don't load that one either, even though it's very light. Again, I don't want to push bytes I don't need. I don't want to push resources down the pipe. And again, there's nothing particularly fancy about this other than the fact that I'm looking at the string that came back in the article and said, does that actual element exist in it before I stamp it? And then based on this, you'll also note that I don't await these. I straight up just run them so that everything else continues to parse and go. I don't need them to wait. I just need them to stamp once they come in. The beauty of custom elements is that when that thing fires up and loads, it'll load within the scope of whatever blog post is there. So again, you're getting async runs against that, right? Your waterfall is not dragged out. You get a lot of very parallel runs with very similar start points, and then you get a lot more perf out of that. And again, you're not looking at much code. You're looking at standard platform code. You can pretty much do this in anything. And the frameworks all have their own different notion about this, but at the end of the day, it does support this. You can do this sort of work. So fundamentally, you can lift this up even higher. So we've talked about depth all the way down, right? Lazy loading of lazy loading. But I also want to be very, very clear about things I should only load when I absolutely have to have them. So this goes to the fact that, well, what if I need to polyfill something? So when people talk about polyfills, I see them get bundled into stuff a lot where they're not really doing the checks to load them only if they need them. Like there's no reason to load them all the time. And in my case, I have a little app starter that it's actually the main hook in the base page. Again, you can do this in any way you want. But realistically, mine looks for really specific little tiny builds of stuff that I happen to use. So in this case, I'm looking for things that don't have that need my little tiny version of the polyfill for web components. Similarly, same thing for intersection observer, and then same thing for dynamic imports, which will support old Edge particularly. All this stuff is really particular to, do I actually need it? Because if I don't need it, I'm not loading this file right here. I'm not loading the polyfill for dynamic import. Similarly speaking, I am not loading the polyfills for web components or intersection observer either. And again, it could be any polyfill you particularly need, so that you can run these particular checks to get you down this path. And again, this is the notion of I need to load these things in certain cases, but not everyone should pay the byte hit and the network request hit just because I need these things. I can break them out of a main pack and decide to load them by doing feature checks as opposed to just saying, well, everybody's going to get them. This is, of course, it can be easier said than done. It really depends on how much you need to ship and what you're trying to do. Certain companies that I worked with in the past, we built really specific polyfill packs that were really tight, that were always the base load and things, so that you would run those feature checks at a much more higher level, very modernizer-like, and then you'd load them if you need them. So you can get a lot of value out of these little things because, again, you're reducing, right? You're reducing the amount of stuff I have to ship, have to parse, user has to load. If we can do that, the purple pattern's working for you. So the purple pattern on its surface, again, it seems fairly straightforward, but the reality is that lots of people don't do this, and you should be doing this. And the one reason that people don't do this is because they don't start at the trace. They don't look and see what the actual thing that they're outputting is, how it actually functions. So you end up with these huge bundle packs, huge stacks of stuff. And fundamentally, if you start with tracing, again, I implore you, just go run a lighthouse trace on something. Run a lighthouse trace locally against the thing. Don't even, just see how things are reacting. Let it do the emulated version of it. You don't have to even have a device on your desk. Just do a base trace. Find those things of what they are before they get so embedded in your applications that you do have to go back through and go, how are we going to retrofit this? Because there is a significant cost to all these things, right? Like, it's not free time to go back through. And you don't want to optimize so much in the front, but you still have to do, and you have to take the hard look. You have to look and say, hey, we need to get there for our users. Otherwise, much like we are all probably experienced lately on the web, given the current COVID situation, which I hope you're all being safe out there and you're doing all right, that the web can be slow. Like, even in, if you thought your internet connection was fast, you're like, wow, my web stuff is just not loading that fast anymore. Well, all of a sudden now, maybe you're starting to feel that hurt a little bit more that some of your users are starting to feel as well, or previously it felt that you just hadn't seen in your traces or hadn't seen in your real user metrics or your real user measurements. So you want to take these things into consideration. That's what you want to do. So purple, all the things, if you can. Read your framework documentation. If you're doing a bare metal on the web, take it into account as well. Because as you can see, which blog PWA is pretty bare metal, you don't need a framework to do it either. So this has been another episode of Web Performance Things. If you found this training helpful and would like to learn more, let us know. We'd love to teach you more. I love talking about web performance, web components, all things web platform. And now this .labs is offering virtual corporate trainings because we know you're all, a significant portion of you out there are working from home. We know how difficult it is, to stay current and stay connected as well. So do let us know if you need virtual trainings to help your devs and or you all out there on the YouTubes to learn more and do more performance things. So I have been Justin Ribeiro. I probably will be tomorrow as well. If you have questions, do ping me on Twitter, Justin Ribeiro. I could just leave the coffee up there. Everybody needs a cappuccino every now and again. You can always find me on Twitter, or you can send me an email as well. And if you have other questions, you have sites you would like to see traced, do start sending us those. Ping this dot on Twitter as well. We would love to trace your site. So this has been another episode. Check the ones in descriptions below. My children told me to say like and subscribe. I'm told that is the proper YouTube outro thing to say. Girls, if you're watching, do let me know if I did that right. Dad loves you. Thanks, everybody. See you next time.